Hi guys, welcome back to our chemistry class. So today we are going to discuss about chemical properties of metals. Okay, so in this session, you please remember that different chemical properties are there. Previous session we studied about physical properties of metals, physical properties of non-metal. I think you maybe remember that. Please recall those. Okay, now in this session, chemical properties of metal, and that is the first point of that is what metals burning in air. Okay, so chemical property of metal when metal is reacting with oxygen, that is what we are studying in this session. Okay, so actually almost all metals are reacting with oxygen to form metal oxide. Not every metal, almost all metals are reacting with oxygen to form metal oxide. Okay, so what is burning? Actually burning is possible only in the presence of oxygen, am I right? And that means what? Reacting with oxygen. Okay, so metals are burning means what? Metals are reacting with oxygen. Okay, so that is what metals, almost all metals are combining with oxygen to form metal oxide. Okay, for example, copper plus oxygen gives copper oxide, aluminium plus oxygen gives aluminium oxide, and all. Copper oxide is black oxide. Okay, you please read this topic clearly, okay, and make notes. Don't forget to that. Please read your textbook. Okay, otherwise you cannot get each and every points into your mind. Okay, so and also magnesium, that is a metal, and it will react with air, give white dazzling flame. That will be visible for us, but due to lack of facility we cannot conduct that experiment. Okay, so remember, magnesium reacting with what? Air, and produces magnesium oxide, that will be what? White flame, dazzling flame. Okay, now please come again. Metals are reacting with oxygen to form metal oxide. This is our basic idea. Now we have to study what will be the nature of this metal oxide. In our previous chapter we studied that metal oxides are basic in nature. Okay, but some metal oxides will be show both acidic and basic character. Okay, and such compounds are known as amphoteric. Okay, amphoteric oxide, metal oxides which react means which shows both acidic and basic characters are known as amphoteric in nature. Okay, and suppose the metal oxide is basic, then it will react with an acid to get neutral compound. Neutral means neutralization reaction. I think you maybe remember neutralization reaction. I don't know, you know. Neutralization reaction is what? Actually acid and bases reacting with each other to form salt and water. If you don't know, then please note it. Neutralization reaction means an acid plus a base gives salt plus water. Okay, so suppose our metal oxide is acidic in nature, then it will react with a base to give neutralization reaction. Suppose our metal oxide is basic in nature, then it will react with an acid to produce salt plus acid, means salt plus water, means a neutralization reaction. So such an example for metal oxide is aluminium oxide. Aluminium oxide is what? It is an amphoteric oxide. Okay, means it shows both basic character and also it shows an acidic character. I think you know what is acid, what is base. Okay, so acidic character and both show basic character also. So the example with a reaction with acid and base of aluminium oxide is provided here. In first case, aluminium oxide plus 6 HCl. HCl means hydrochloric acid. So that means here aluminium oxide is what? It is a base. Gives AlCl3, it is a salt plus H2O, it is water. Neutralization reaction is done. Now next example, Al2O3 plus NaOH. NaOH means sodium hydroxide. It is a base. That means here Al2O3 is what? It is an acid. Here aluminium oxide is an acid. Okay, so this is reacting with each other to produce NaAlO2, that is sodium aluminium. It is a salt plus water. Okay, so this is what about the characteristic property of metal oxide. What? Metal oxides are basic in nature, but some metal oxide shows amphoteric behavior. Example for that is what? Aluminium oxide. Amphoteric behavior means it can show both acidic character and also show basic character. Okay, and proof of that is what? If it is acidic, then it will react with a base to produce neutralization reaction, to get neutralization reaction. If it is acid, it is reacting with base. If it is base, then it is reacting with acid. Okay. Now, another property of metal oxide. Metal oxides are generally insoluble in water. Okay. But some metal oxides are dissociating in water and produces alkalis. Okay. What is insoluble? Insoluble means it will never differentiate into its constituent particles. Suppose AB, it is a metal oxide. Then it is what? Soluble means it will, yes, dissociate at A and B separately. But it is insoluble mean it will remain as such AB in water. Okay, without dissociation it will remain as such. That is what? Insoluble. So, but some metal oxides are what? Are soluble in water and dissociate to form the product, and if they are soluble, that means it will produce alkalis. Alkalis will be the product. For example, sodium oxide and potassium oxide. Sodium is a metal, potassium is a metal. Sodium oxide reacting with water and it is dissociating and it is producing sodium hydroxide. It is an alkali. Potassium oxide is a metal oxide. Potassium is a metal. Reacting with water produces potassium oxide. It is what? It is also an alkali. Means it is a base. Okay. So this is what about solubility in water. Okay. So we studied 2 points here. Nature, acidic basic nature of metal oxide. And next one, solubility of metal oxide in water. Most of are insoluble, but some sodium oxide and potassium oxide are soluble in water and produces alkalis. Okay, now here in this session, it means in the last paragraph, saying that different metals are reacting with air in different rate, and that will be very clear to understand that gold is a metal, but it is not reacting with air. That means what? It is inactive with air. So you can understand the rate of metals. Different metals have different rate with reaction in air. Okay, so you please read this passage completely. Okay, and at ordinary temperature, the surface of the metals such as magnesium, zinc, lead, etc. are covered with a thin layer of oxide. Okay, to protective, it acts as a protective oxide layer, prevent the metal from further oxidation. What is it actually? Means metal is what? Oxidizing in air. Okay, and form metal oxide. But at ordinary temperature, the metal is already oxidized with air and it have a coat of, means it have a covering of its own metal oxide, and that covered metal oxide will prevent the inner metal from further oxidation. Okay, that covered metal oxide will prevent the inner metal from further oxidation. Okay, I think you may be clear. Aluminium, for example, aluminium I am taken, exposing to air. So the outer surface of the aluminium will produce aluminium oxide. Okay, and the inner core of the aluminium will remain as such, because it will not expose to oxygen. It will only exposed now with the aluminium oxide. Okay, so that is what? Protected from the atmospheric oxygen. Okay, so this is what? A natural process. Okay, now iron does not burn on heating, but iron fillings burns vigorously with heating. Copper does not burn, but copper coated with a black colored layer of copper oxide. That is what? The outside of the copper reacted with oxygen and formed copper oxide. Inner side does not burn. Okay, now silver and gold not reacting with oxygen. You know that even at high temperature, because our gold ornaments are remaining as such always. Okay, so that is what about. Now I told you that aluminium reacting with the outer surface of aluminium reacting with oxygen and forms aluminium oxide, and this is what actually known as anodizing process. Okay, you read the box provided here. Anodizing process. Anodizing is a process of forming a thick oxide layer of aluminium. Aluminium develops a thin oxide layer when exposed to air. This aluminium oxide coat make its resistant to further corrosion. What I told you, that itself. Okay, and this process is known as what? Anodizing, which is what? Protecting the inner aluminium. Okay, protecting the inner aluminium from further, yes, oxidizing with metal. Okay, you please read these passages. Okay, so this is what about our today's topic. So I think you maybe remember whatever we studied. Whatever we studied, metals are reacting with the oxygen to produce metal oxide. All metals are reacting with oxygen to produce metal oxide. And the nature of metal oxide. Generally, metal oxides are basic, but some metal oxides are amphoteric in nature. Example is aluminium oxide. Next, reaction with water. Metal oxides are what? Insoluble in water, but some of the metal oxides soluble in water. Example, sodium oxide and potassium oxide, and they are producing alkalis, corresponding alkalis. Sodium oxide reacting with water to produce sodium hydroxide. Potassium oxide reacting with water to produce potassium hydroxide. Okay, then we studied about the prevention method, means anodizing process. Okay, sacrificing method, we can say as also sacrifice. Okay, so that is also known as galvanization. The term for that is anodizing process is also known as what? Galvanization. Zinc is coated with a zinc oxide layer, and then further oxidization of the inner zinc will be impossible. That means what? A galvanization, and so on. Okay, so you please note down the term galvanization. Okay, there is no need of study that, because you don't have there is not in your textbook that term. So if you want, then you please note it out. Okay, so this is what about our today's topic. If you have any doubt, please contact me frankly in our group. Don't forget to contact. Okay, and also after listening to today's class, you have to give me the feedback if you understood or not about that. Okay, so make notes. I will say the date to submit the note. Not today. Okay, you make the note today itself, but I will say you immediately the date. Okay, so that is what about. Yes, this is enough for us. Have a nice day. Bye bye.